So far we have studied Bernoulli trial and binomial distribution. Now we will study mean of binomial distribution. In random variable, we studied that mean of a random variable x is denoted by e of x, where x is random variable and e means expected value of x, and it is equals to sum of xi into pi, where pi is nothing but p of x equals to x. Now we also studied that p of x equals to x also means that x number of successes in n number of Bernoulli trials. So it can also be written as ncx into q raised to power n minus x into p raised to power x, where p is probability of success and q is probability of failure, and p plus q is equals to 1. Now in this case x will be varying from 0 to n, and from here we would like to obtain a simpler expression to calculate the mean of x. So to further solve this, we'll write this ncx in the form of factorial notation. So it becomes n factorial upon x factorial into n minus x factorial, and this x factorial can be written as x into x minus 1 factorial, and this x will get cancelled with this x. So finally this becomes n factorial upon x minus 1 factorial into n minus x factorial into q raised to power n minus x and p raised to power x, and in this case the summation will be varying from x equals to 1 to n. Why this has happened? Because if you put x equal to 0 in this case, this becomes 0 minus 1 factorial, which is not defined. So that's why x will be varying from 1 to n. Now to obtain a simpler expression, we will do two manipulations. One, we will put x equals to y plus 1, and secondly we will put n equals to m plus 1. So after doing this substitution, the expression we obtain is e of x equal to summation 0 to m plus 1 factorial. Wherever there was n, it became m plus 1. This x minus 1 became y, and this n minus x became m minus 5. This became m minus 5, and this became y plus 1. Now in this case the lower limit of y will be 0, because in this case since x was tending to 1, so y will be tending from 0. So lower limit of y will be 0. Now this m plus 1 factorial can be written as m plus 1 into m factorial, and m plus 1 since is a constant number, so m plus 1 can be taken out of summation. So m plus 1 has been taken out of the summation, and this p has been taken out from here also. So p is also a constant number, so p has come out of this summation. So we are left with m factorial upon y factorial into m minus y factorial into q raised to power m minus y into p raised to power y, and here a value of y will be varying from 0 to m. If you look here very closely, this is nothing but binomial expansion of q plus p raised to power m, and we know that q plus p is equals to 1, so this becomes simply 1, and this m plus 1 is nothing but n. So finally we obtain expression of ex equals to np, and this is mean of binomial distribution. Let us now look at variance in case of binomial distribution. In case of random variable, we studied that variance of random variable x is given as e of x square minus e of x whole square. But in case of binomial distribution, we apply this expression which says variance of x is equals to npq, where n is number of Bernoulli trials, p is probability of success, and q is probability of failure. And this is the expression that you must remember. If you want to know how this expression has been obtained, then you can look at this proof, and you can also note it down, and this proof is also available in various standard textbooks. But the most important relation for us is this expression. So this is variance in case of binomial distribution.